All right, so today we're diving into machine learning. And something tells me you're the kind of person who likes to know how things actually work. And with AI becoming more and more a part of our lives every day, it's a really good question to ask.
Yeah.
It's kind of wild when you think about how much AI is already out there. Like, did you know that ChatGPT hit a record 100 million users in just 2 months?
It really is incredible. And, it might feel like magic sometimes, but the ideas behind AI, especially machine learning, they're actually pretty easy to understand.
Okay.
Like, think about it. You probably use AI every single day and don't even realize it. Like Google Docs, finishing your sentences, or Grammarly catching that comma splice you missed. All
Mm.
those are AI working behind the scenes.
Okay, so it's not all like science fiction robots then.
Right.
Which brings me to a question when we talk about machine learning, what are we actually talking about?
Well, at its heart, machine learning is about teaching computers to learn from examples just like we do.
Mm.
Instead of like programming a computer for every single task, step by step, we give it tons and tons of data and let it figure out the patterns all on its own.
Now,
It's like showing a child thousands of pictures of cats and dogs. Eventually, they start to pick up on the differences, right?
right.
Machine learning does the same thing, just with data instead of furry friends.
So it's like teaching by example, but on a massive scale.
Exactly.
And this visual, you've included this model work scheme.
Mhm.
It really helps visualize this. Like we feed in some input, like a picture of a cat,
Right.
and the machine learning model, which is kind of like the computer's brain,
Yeah,
it processes that and then tells us, hey, that's a cat.
exactly. And depending on what we've trained that model to do, the output could be anything. Like it could be identifying a cat's breed or predicting its next move. I mean, the possibilities are pretty crazy.
Now, where does deep learning fit into all of this?
Right.
It sounds so complex. Are we talking about like supercomputers thinking deep thoughts?
Well, deep learning is actually a type of machine learning that's specifically inspired by the structure of our brains,
Okay.
particularly what are called neural networks. It's like taking inspiration from the most powerful learning machine we know of.
So we're building computer brains now.
Well,
That's amazing and slightly terrifying.
yeah, don't worry. We're not quite at the robot uprising stage yet.
Okay, good.
But it is fascinating. Neural networks have a pretty long history. John Hopfield, he pioneered the first one back in 1982.
Mm.
And then in 2006, Geoffrey Hinton, who just recently won a Nobel Prize for his work,
Wow.
he made a huge leap forward with deep learning.
Okay.
He basically showed how to use these artificial neural networks, but with many layers, hence the name deep, to analyze tons of data and find these super complex patterns.
I'm looking at this visual comparing the human brain neurons to the artificial neurons in a deep learning network, and they look surprisingly similar.
Yeah, that's the point. While these artificial neurons are very simplified versions of the real deal,
Yeah.
they function in a pretty similar way.
Okay.
They connect and process information in these layers. And just like our brains, the more layers there are, the more complex the network's thinking can be.
So how do we actually train these models to do all these amazing things?
Right.
Is it like giving a computer a giant stack of flashcards?
It's more about practice, just like with humans.
Okay.
Think about learning to play the piano. You start with those simple scales, you make mistakes, you adjust your technique, and then you gradually get better.
Right.
So in machine learning, we train a model by feeding it data and letting it adjust what are called its internal weights based on how well it performs.
Mm-hmm.
These weights are like tiny little knobs that the model tweaks to get better at its task.
And there's this visual here showing these weights changing during training, which helps make it feel more real.
Yeah.
But speaking of the real world stuff, training these models must cost a fortune, right?
Wow.
I read that GPT-4 cost something like $78 million to train,
Wow.
and Gemini Ultra even more, almost $200 million. Is it all about just throwing money at the problem?
Well, cost is definitely a huge factor, and it mostly comes down to the sheer computing power needed to process all of that data.
Yeah.
Like GPT-4, for example, was trained using 30,000 NVIDIA A100 GPUs.
Wow.
That's a lot of processing power.
30,000 GPUs. I can barely afford one for my gaming PC.
Right.